I think the only thing that was different here in this lesson or this assignment was the fact that you're dealing with repetitions, which means identical items. So for example, this is all just kind of review here. But when you get to the next section, or even stuff like this, you have to use the concept of identical items. So if you had to arrange all of the letters of the word monotonous without any restrictions, you would just say that it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factorial, and then you would start keeping track of all of the items that are identical. I see 4 O's, which would mean you would divide by 4 factorial. That's the rule we learned yesterday. I see 2 N's, and right away my brain is starting to get a little bit lazy here because I'm not following some procedure. I'm just seeing a whole bunch of letters and hoping I see patterns. So as I said yesterday, it's a good idea to just cross things off as you use them. 1, 2, 3, 4 O's, 1, 2 N's, a T, a U, and an S. So that would be the answer. Can you take a look at your work, please, and see if you have any questions you would like me to go over? Annalie? 10. 10? This one right here? Okay. Well, it doesn't actually give you the diagram, does it? And I know what's going to happen here. You're going to see the numbers 10 and 8, and you're going to do what I probably would have done the first time I saw a question like this. You would say, since there are 10 streets and 8 avenues, that you need to make 18 moves, okay, which is not actually correct. And I'll show you why in a second. And then you would divide by 10 factorial, 8 factorial. But this, in fact, doesn't work, and you've discovered that because I'm sure that's what you did. If I draw this, and you're not going to have to draw it, I don't think, once you see it. Go ahead and count the streets there. 1, 2, 3. I've labeled them 1st Street to 10th Street. There are 10. But because there's 10 streets, if you start counting how many blocks I have to walk, it's only 9, right? Because we start right on 1st Street and 1st Avenue. So I need to make a move to the right 5, 6, 7, 8, 9 times. I need to make downward moves 1, 2, 3, 4, 5, 6, 7 times. And that probably answers your question. In fact, it's going to be 17 factorial, pardon me, 16 factorial over, there are 9 moves to the right, so 9 R's that are identical, and there are 7 down, so that would end up giving you the answer. Yeah?
So when it says blocks, we can use the numbers given, and when it says streets, we have to do it?
Yes. What's just being asked is if it's blocks, if it said you have to walk 10 blocks west and 8 blocks south, then yes, you would use the 10 and the 8. I don't know how often that would happen. Almost always it's the case that you're given a picture, a diagram. Other questions? Go ahead, Grace. 9. Okay. So how many, this is confusing because it's not just all of the letters for some of these questions. So what are the number of arrangements of the letters of the word tattoo if it has to begin with a T? I guess we are arranging all of the letters, okay, but it has to begin with a T. So there are at least two ways that you can think about this. When you look at the word tattoo, there are 6 letters. I hope everybody understands that when you have arrangements where there are conditions, it's never going to be as simple as NPR. It's going to be the fundamental counting principle. And this must be a T. So how many T's do you have to choose from? You have 3 T's to choose from, okay? And then you have to fill in the remainder of the blanks. But you're down to 5 letters, correct? So then it would be 3 times 5 times 4 times 3 times 2 times 1. But this is not going to work. And the reason it's not going to work is we still have to divide by the repetitions. So whatever number this is, we need to divide it by 3 factorial, 2 factorial. And you're going to get I believe, 30, but I don't know. And is 30 the answer? It is, okay. See, I wouldn't do it that way. And right away, just want to make sure you do get 30. Yeah, you get 30. Right away, when I start doing this, I'm confused, and I'm being honest with you. It's confusing to me. I lack confidence in doing this question this way. There's something about it that just is screaming, I think you're doing this wrong. So what I would probably do instead, and you might say, well, it doesn't really change things that much, but to me it does, is since the first letter must be a T, let's just ignore that first T and say that's the one that goes there. And then what I'm doing is I'm arranging 1, 2, 3, 4, 5 items where I have 2 T's and 2 O's. That should still give me, well, it's 120 divided by 4, it still gives me 30. It begins with 2 T's. Now, if it begins with 2 T's, that's different than begins with exactly 2 T's, okay? So, is this an arrangement that begins with 2 T's? Yes, it is. So the fact that it has to begin with 2 T's doesn't preclude the idea that it could begin with 3. But the only thing that's important, and again, I think the fundamental counting principle is the only viable path you can take here, is to say this has to be a T and this has to be a T. So there are 3 T's to choose from and then 2. And now I'm down to 4 items left, so it's 4, 3, 2, 1. But in all of that, I have 3 identical T's and 2 identical O's, so I need to divide that by 3 factorial, 2 factorial. And that, by the way, is coincidentally going to give me 30 as well, I believe. No. It's going to give me 12. My mistake. Go ahead, Kendra.
Would you have just taken out the 2 T's and then done the equation? Like taken out the 2 T's and then just done 4 factorial over 2 factorial?
I think that will work. For some reason, it will. For some reason, it makes more sense to take out a T and A, in my mind. But in taking out 2 T's in B, I'm a little leery about doing that. But I don't see why it shouldn't. Because what you're really doing then is here's the thing that you have to make sure you don't get confused by. You're really saying that these are the 2 T's you're using. And by doing that, you're kind of saying that they're not identical. This is the T that goes first. This is the T that goes second. But sure, I don't see why that wouldn't work. Let's load up the first couple of spaces with those. So really the question is, how many ways can I arrange the remaining 4 items, which is 4 factorial over the 2 factorial. Now, when it begins with exactly 2 T's, I'm going to jump around a bit here. Exactly 2 T's means T, T, not T, that means not T, and then whatever. So this is 3 and then 2, and then you have 4 letters left, but one of those 4 is a T, and we don't want the next one to be a T, so we're down to 3. Now we have 3 left, and then 2, and then 1. You still have to divide by 3 factorial, 2 factorial. You could, along the lines of what Kendra said, for E, simply say, these 2 T's that I've crossed out are the first ones, so the question is, how many ways can I arrange these 4 letters so this is not a T? And it would be 3 that are not T's, and then 3 times 2 times 1, but you would divide by 2 factorial. Would you like me to do C and D as well? You think you could piece them together there? When I look at C, I would just forget about the T's. If it's got to begin with 3 T's, then that's done. How many ways can I arrange the remaining 3 letters? Other questions? All right. We are moving on today and looking at combinations. So this is the next lesson in your unit handout. I believe this is on page 22 if my numbering is right. There's a difference between a permutation and a combination. And I already talked to you about this at the beginning of this unit, which was midweek last week. And that's basically that a permutation is an arrangement of items, and that means that the order in which they're listed or presented or looked at is part of the problem. Whereas a combination is just a selection of items without regard to the order in which they're selected. You can think of a permutation as being a selection of items that are then arranged, if you like. We're going to be solving equations involving combinations, solving problems involving combinations, and reviewing what the difference between permutations and combinations is. As a warm-up, consider a group of people: Alan, Betty, Charles, and Danny. I hope it's not lost on you that that is A, B, C, and D. Okay? So we have 4 letters, A, B, C, and D, or 4 people. How is it different when you select a president out of that crew, a vice president, a secretary? How is choosing those 3 people out of that group of 4 different than saying that I want 3 people to be chosen to be a judge in a talent contest? Jack?
For this one, it doesn't specify that any person can't hold more than 2 positions, so any of them could fill all 3 possibly, and if it were 3 people to be judges in a contest, then it would have to be 1, and then they would have a pool of 3 to select, and then 2, and then select 1 from that pool.
I get that, but the intention is you cannot serve more than 1 position. Everything you said is logically correct, and I've never thought of it that way before. My intention in this question is that if Alan is president, Alan cannot be vice president, and he cannot be secretary. So next time I do these notes, I'm going to make a note to say that you can only serve 1 position. Okay? So the fact of the matter is, the president, vice president, and secretary will be 3 different people, and the judges will be 3 different people. So it has to be different in another way. Annalie?
For the president, vice president, secretary, everyone has a different job, like it's 3 separate positions, and in judges it's all the same.
Right. And I'm glad you said what you said, and I'm crafty about choosing this as a warm-up. You said positions. And positions in English can mean a couple of things. It can mean your title, president, vice president, or secretary, or it can mean position, location in a list. So if I have 3 people that are judges, they're judges. Nobody is more important of a judge than anybody else, which means if I have 3 judge seats at this contest and they decide to change seats, it's still the same set of judges. But if I around the table have a chair, and in front of the chair on the table is a plate, a nameplate that says president, then the president has to sit there. It's important. So basically, these are positions, so order is important. That's what this boils down to. And I'm going to give you some illustrations here of specific selections and arrangements that demonstrate this. Whereas order is not important for the judges. This would be equivalent to me saying, I'm going to take 3 of you out for ice cream. I'm not, so don't get your hopes up. And it's the middle of winter anyway. I'm going to take 3 of you out for hot chocolate with marshmallows in it. That would be like me picking 3 judges. Or I'm going to pick 3 people, and one of you is going to get a Tim Hortons gift card for $5. One is going to get a BP gift card for $20, and one is going to get an Earl's. Is Earl's still around? It is, wow. An Earl's gift card for $50. Depending on who gets what card, that's a different situation. Is Earl's any good still?
It's the #1 restaurant.
Is it really?
Yeah.
It was a long time ago when I was in university. So ABC is different than BAC, in other words. And I'm actually using an order here. I'm saying that A that A is the president, B is the vice president, C is the secretary. So that would be different if I did this, right? Betty is the president, Alan is the vice president, and Charles is the secretary. Whereas, I don't know if you noticed what happened here. I changed it from judges to judge, judge, judge. They're just 3 judges. ABC, Alan, Betty, and Charles are judges. BAC, Betty, Alan, and Charles are judges. There's no difference in the reality of the situation. I admit sometimes it's going to be difficult when you read certain problems to decide, are we talking about something where order is important or not? It's not always very simple to figure out. So A is a judge, B is a judge, C is a judge. They're all judges. There's no difference between the 3. All right. The number of different ways in which a president, vice president, and secretary can be selected is 4p3. Right? Because order is important. It's a permutation. I could use the fundamental counting principle with 3 blanks and say it's 4 times 3 times 2. But it happens to be 24. Can you confirm 4p3 is 24? It's 4 times 3 times 2. You could do it that way as well. And again, like the other day, I kind of have maybe too much time on my hands sometimes. Or I could be using it more wisely. I've listed all 24. So for example, this one means that Betty is president. Is it Danny? Danny is vice president and Alan is secretary. This means Danny is president, Alan is vice president, and Betty is secretary. So those are the 24. Now, we're going to use this list to determine how many ways there are to select 3 judges. So if we take a look at that list, every item in the top row, I put this list together in a certain way. Every item in the top row, I don't know if you noticed this, Danny is not in. And that means that all 6 of these are really the same group of 3 people. So if this is president, vice president, and secretary, as soon as I go to judges, these groups collapse. The only unique combinations of those 3 people are Alan, Betty, and Charles, Alan, Betty, and Danny, Alan, Charles, and Danny, and Betty, Charles, and Danny. Every single other one of these is already including those 3 people. So the number of different ways to select 3 judges is merely 4. And you might have been able to figure that out because the number 4 is pretty small and we're only selecting 3 out of 4. But if the numbers got bigger, it's more complicated. Well, the number of arrangements of 3 items, which is called a permutation, is 24 out of 4. The number of combinations of 3 items out of 4 happens to be 4, and there's a connection here. And the connection is that you divide the permutations by the number you're choosing factorial. The reason why it goes from 24 down to 4 is we're dividing by 6. I mean, you could also say we're subtracting 20, but I'm telling you what the rule is. You divide by the factorial of the number of items you're selecting. So, when selecting a group of individuals from a list, and the order in which they are selected is not important, you're selecting a combination, and if order is important, you're selecting a permutation. And if the individual items are assigned specific positions, then order is important. I think you get that, right? Am I safe to say that you guys get that idea? Okay. So let's get now to the nuts and bolts of it. When finding permutations, that's the formula, right? And R in that formula is the number of items you're arranging. But we said combinations is the number of permutations. This is what we said. If you take the number of permutations and divide by the factorial of the number you're choosing, you get the number of combinations. That's what we said. I'm using notation here, but we said 24 divided by 3 factorial gives you the combinations. That means that this is the formula. Don't worry about the second one. This top thing is the formula for combinations. Notice there's that extra r factorial on the bottom because you have to divide by r factorial. Now, if I had 4 choose 3, C for choose. It's combinations, but choose is a nice word to use. That can be written as that. They mean the same thing. So from now on, when you see those tall elongated brackets with 2 numbers, it means N choose R. There is no equivalent type of notation for permutations. This always means combinations, always. Okay. All right. Now, the thing you need to try to remember about combinations is not to overcomplicate things. You can overthink these. How many ways can 4 students be selected to go on a trip out of a class of 15? 15, choose 4. You have 15 students, you've got to choose 4. That's the answer. And if you want, you can take 15 factorial over 15 minus 4 factorial, 4 factorial. I don't know anybody who wants to do that. Or you can just use your calculator, right? I hope it's not lost on you in all those times you went to the factorial and to the permutations function that there is a combinations function. The answer is 1,365. That's how many ways I could, if I had 15 students, that's how many ways I could select 4 of them to take for ice cream or whatever the job is. On a student council, there are 8 females and 7 males. We want to pick 6 students out of that 15. Don't overcomplicate things. If there are no restrictions, how many different committees can you create? And maybe I'll stop for a second. Committee, by definition, means a group of people with no positions. Okay? It's 15 people in total. Choose 6. That's the answer. Which gives me 5,005. Sometimes there's a neat kind of symmetry to some of the answers for combinations. There's a mathematical reason for it that we'll probably end up exploring a little bit later. And this is where in B it gets like, wow, how am I going to do this? It's really simple. It's as simple as Bobby Bear picking a pair of pants and a shirt, except you need to choose 3 females out of 8, and, which means times, out of 7 males, you must choose 3. This is the answer. And I hope everybody sees how I could easily make this a numerical response question and say the number of ways this can be done is A choose B times C choose D, and ask you to fill in A, B, C, and D. There would be at least 2 different answers that would be correct. Well, there would be 2 different answers that would be correct. 8, 3, 7, 3, or 7, 3, 8, 3. Do we have a number here?
1960.
1960? Seconder? Okay, good. There must be at least 1 male. Holy smokes. Which means you could have a committee with 1 male, or 2, or 3, or 4, or 5, or 6. So, do not write this down. This is not how you would do the problem. If you want to, you can, but I wouldn't recommend it. 1 male and 5 females would satisfy the condition here, or 2 males and 4 females, or 3 and 3, or 2 or 4 and 2, or 5 and 1, or 6 and 0. So when you do this 1 male and 5 female selection, you would have 7 choose 1 for the 1 male out of 7, and 8 choose 5. The word or means add. So take a look at that 7 choose 2 and the 8 choose 4. I've tried my best to line things up here, you know, so that this is this and this is that. But are you seeing where, there we go, are you seeing where this 7 choose 2 and 8 choose 4 is coming from? Okay, and then you would just continue. You would say, well, 7 choose 3 and 8 choose 3. Multiplication plus, because or means plus, and I think you get the idea. But you see how tiresome of a task this would be? So there's got to be another way to do it. By the way, if you do all that, you get 4977. The other way to do it is this way. It's to say, let's find out the total number of committees, which is 15 choose 6. And we found that already. I think, was that the 5005? Yeah, that's 5005. And this is very similar to how many ways can Joan and Emily not be together? We find the number of ways that Joan and Emily are standing next to each other and take it away from the total. This is a little bit different though. If we want to find out how many committees have at least one male, there's only 2 options. A committee will have a male or not. So what we're going to do is find the number of committees with no males. Now, if there are no males, you need 6 females, and what many people will write, and I'm actually a little surprised that I didn't, is also 7 choose 0, because out of 7 males you're choosing nothing. 7 choose 0, by the way, is 1. Right? You have to choose 6 females out of 8 and 0 males out of 7. You certainly don't need to put that 7 choose 0 there. Okay? But that works out to 28. So the number with some males, which is at least 1, would be the difference between those 2 numbers, which gives you 4977. I want to just throw something out here, and we're not going to necessarily do this problem, but this is question C. Question CC, what if I said 2 or more males? Well, we could go back and do all this, but not include this one, right? Or we could take that 5005 and subtract the number of committees with no males and also subtract the number of committees with 1 male. And I hope you see that as this number 2 gets bigger and bigger, it might be easier to just do it from the other end and find them individually rather than doing a subtraction thing. But if I had, 14 people on the committee and I said at least 1 male, you don't want to do it the long way. All right, D, Jimmy, who is the principal's son, must be on the committee. And I will admit I'm using very traditional male-female approach to these problems. We're assuming Jimmy is a boy because it says son. He's male. Well, if Jimmy's son, because of nepotism, which means favoritism, if Jimmy's son has to be on, not Jimmy's son, the principal's son has to be on the committee, then it's already decided. What you really have here is 1 Jimmy, and you have, was it 15 people in total? You have 14 non-Jimmys, right? And along the lines of if the first letter must be a T, you could just take the approach, if Jimmy is already there, then let's not worry about Jimmy. The answer is 14 choose 5, because we need 5 more people to fill up the committee. If you want to be pedantic about it, which means picky, then I suppose you should do this. You need to choose 1 Jimmy and 14 non-Jimmys. So 1 choose 1 times 14, not 14, 5 non-jimmies. So out of 1 jimmy, you need to choose 1 jimmy. Out of 14 non-jimmies, you need to choose 5. And I think 14 choose 5 we did already, wasn't it 1960, or am I thinking of something different? I'm thinking of something different. What is it, Grace? 2002. 2002. There's that symmetry that we often bump into with combinations. Can you just, first of all, on your calculator, confirm that 10 choose 3 and 10 choose 7 are the same number? I don't know what it is, but can you tell me, Grace? 21. So 120. 120. So 10 choose 3 is 120, 10 choose 7 is 120. Why do we get the same number? Kendra?
Because 3 plus 7 is 10, so no matter which order you put them in, it's the same.
So, and I don't mean to put words in your mouth, but first of all, the observation that's important is the 7 plus the 3 gives you 10, and this is only going to work if that's true. I don't want to put words in your mouth, but are you saying that when you use this formula, that you're going to get on the bottom 7 factorial and 3 factorial no matter what? And you're absolutely right. If you apply it to 10 choose 3, if you apply it to 10 choose 3, then you have 10 factorial over 10 minus 3 factorial, 3 factorial. If you apply it to 10 choose 7, you get 10 factorial over 10 minus 7 factorial, 3 factorial. So there's a mathematical approach to a justification of why you get the same number. Perfect. Is there a real life reason why we have to get the same number? The number of ways, there are 11 people in here, but let's just pretend there are 10, okay? Let's just imagine there are 10 people in here. Is there a reason why the number of ways for me to choose 3 out of a group of 10 has to be the same as the number of ways for me to choose 7 out of a group of 10? Lucas? You're just scratching your head? Okay. Annalie?
Because if you're choosing 7 people, then you're technically choosing 3 people too, because there's 3 people left over.
Right. I'm making a decision to divide the group somewhere, and that's my choice. That's the decision. I'm choosing these 3 people. The example I use is if I had 10 people in the room and I'm going to take 3 of you out for ice cream, then maybe I'm not choosing 3 people to take out for ice cream. Maybe I'm choosing the 7 people I do not want to be eating ice cream with. Maybe that's what's going on in my head. I'm not. You know me. I'm a nice guy. But I'm saying when I choose a group of 3, I'm choosing not to choose the remainder of the group. And there's so many ways that you could explain that. I don't think it's really that important that you write down everything here, but as soon as you choose 3 items out of a group of 10, the 7 unchosen are a selection. They're a group that's selected. They're selected not to be selected, but they're still selected. And sometimes you might see this on an exam where you might have the following question. I've never seen this specific one, but I think it's a decent one. Bad example. What is the value of K? And I know, you look at it and you go, what? All of a sudden we're talking about ice cream and picking people and judges, and now what are we supposed to do there? Since these 2 numbers are both 20, this is 3, this could be 3, or this could be 17, couldn't it? So there are a couple of answers here. One of them is the number that k can take on to give us 3, but that would probably be given in the question that if that k plus 17 is not 3 or k plus 19 is not 3, what's the value of k? The answer is this would have to be -2, because -2 plus 19 would give you the 17. And it's not even an algebraic problem, it's just a thought problem. All right. 5 different types of topping for an ice cream sundae. You want 3 toppings. You're going to choose 3 different toppings, but one has to be chocolate because, right? That's just the way it's going to be. You're not allowed to choose chocolate, chocolate, chocolate. Okay? You have to have 3 different types. Sorry about that. So how many different sundaes could you choose from? Well, if you've already chosen chocolate, then there's 4 toppings left and you need to choose 2. 4 choose 2. That's the answer. Which I believe is 6. How many of you, does anybody play crib? You know, if you have 3 of a kind, it's worth 6 points, right? 3 kings. If you have a pair of kings, it's worth 2 points. If you have 4 kings, anybody remember what it's worth? It's worth 12. And this isn't a random thing. The reason is, if you have the king of hearts, the king of diamonds, the king of clubs, and the king, well, you get it, of spades, how many pairs do you have? You've got 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs, 6 pairs. You're choosing a total of 6 different pairs because 4 choose 2 is 6. That's why you get 12 points. 3 choose 2 will give you 3, and each pair is worth 2. If you don't play crib, none of this makes sense. Okay. In a classroom, when each student shakes hands with every other student, there are 300 handshakes. How many students are in the class? Seems like, are you kidding me? Out of left field. But in order for there to be a handshake in this room, there are 11 students in this room. For each handshake, you need to choose 2 people. So if I said to you, how many ways can you shake hands with everybody and everybody shake hands with everybody else? In this classroom right now, it would be 11 choose 2. Because of the 11 students, you need a pair to get a handshake. So what this question is really saying is, n choose 2 equals 300, and solve it algebraically, which is a classic written response question on a diploma exam. I see it very often. You go to your formula for n choose r, which is n factorial over n minus r factorial, and this becomes n factorial over n minus 2 factorial, 2 factorial, and 2 factorial is 2, right? We got to add that extra r factorial because it's a combination. How many of you know where we're going to go from here? Because we've done this before. We just didn't do it with combinations. Jack?
Multiply by 2 factorial.
Okay, so I can change this to 600 over here. True. And I'm going to do that in a little bit. But what are we going to do about these other factorials? Grace?
Expand the top, so it would be n minus 1, n minus 2, and then we'll cancel.
That's right. Expand the larger of the 2 factorials because the smaller of the 2 factorials is a factor of the larger. So we're going to have n factorial is n times n minus 1 times n minus 2 times n minus 3 all the way down the line. This time I'm going to put this to model what I think would be a good idea on a written response for you as a student. I think this would be wise to do that. And I think it would be wise to indicate that this is n minus 2 factorial. Of course, this is equal to 300. It's also, well, we can multiply both sides by 2 here, can't we? I don't see why not. And this is over n minus 2 factorial. So this entire thing is a wash with that thing. They're gone. And you're left with n times n minus 1 equals 600, which we recognize as being quadratic. Now, I'm just going to give you a tip here. This has to be factorable because n has to be a number. We don't have part of a person, whatever that would mean. I mean, a person is a person. So we know that this is going to factor, and the two, listen very carefully to this because I think this will be helpful. The two numbers have to multiply to give 600, but they have to add negative 600. They have to add to give negative 1. The fact that they add to give negative 1 means they're really close together. So I'm just going to take the square root of 600 and see what number that is, and then maybe look at the numbers on both sides of it. That's not a guarantee to work. Because quite frankly, I'm not good at looking at numbers like 600 and going, oh, it's this number times that number. 600, the square root of 600 is 24. So maybe 25. What's 600 divided by 25?
24.
It's 24. Oh, there you go. So it's going to be minus 25 plus 24, which means n is equal to 25, or n is equal to negative 24. Excuse me. When you're doing a written response and you dismiss this out of hand because it's obviously wrong, if it's a written response, you really ought to put a reason. N is the number of students, so n must be a natural number. And if you want to really impress the markers, you can say n has to be more than 2, obviously. Well, it has to be bigger than that even, obviously. But anyway, n is 25, so the answer to the question is 25 students. And you can very clearly confirm that on your calculator by just going 25, choose 2, which brings up another important point. If I put in for y 25, choose 2, and I use my table, whoops. If I put in 25, x, we don't know it's 25 yet. If I put in x, choose 2, and I go to my table, and I scroll down to discover that the answer is 25, nobody who's marking my exam knows how I know it's 25. So you could just go down here to the bottom and go, well, it must be 25 and some other number, right? You could reverse engineer how it should factor. How many different 4-letter arrangements are possible from any 2 letters from the word smile and any 2 letters from the word frog? This is the same as me saying, I have 5, S-M-I-L-E, I have 5 German thrash metal songs, and I have 4 classic rock songs. How many different 4-song playlists can I make with 2 from each genre? What do I have to do to complete this task? Well, I need to choose, of these 5 letters in the word smile, I need to choose 2 of them. And of the 4 letters in the word frog, I need to choose 2 of them. Is there anything else I need to do? What else needs to happen here? Let's say you choose M and I, and you choose R and O. What are we asked for? We're asked for arrangements of those letters. Not only can the M and the I go over here, the M and the I could go in between the R, or it could be R-I-O-M. I need to take those 4 items that I've chosen and arrange them. So I need to multiply by 4 factorial. Or you could write 5 choose 2 times 4 choose 2 times 4p4. I have no idea what this works out to, though. Can you help me out? 1440. 1440? And can we get a seconder there? Okay, good. The idea behind all of these kind of rapid-fire examples is to get you to recognize some of these problems when it comes to an exam. How many diagonals are in a 12-sided polygon? Like, speaking of out of left field, how many diagonals are in a 12-sided regular polygon? Well, let me draw one for you. That's a 12-sided regular polygon. What's a diagonal? Carly?
Like across from each other?
Yeah, from vertex to vertex, or from corner to corner. This is a diagonal, this is a diagonal, this is a diagonal. Any line connecting what I call vertices, plural of vertex, is a diagonal. The question is, if there are 12 vertices, then how many ways can I get a diagonal? Well, each diagonal is 2 vertices, correct? So it really makes sense that it would be 12 choose 2. But it's not. Any idea why? Isaac?
Is it because that 12 choose 2 would only be for one vertex and it's not from all the other ones that it...
No, it actually is for all the vertices. If I had 12 nails in a wooden board and I nailed them in this shape, and I took elastic bands and I connected them in groups of 2, 12 choose 2, whatever number that is the number of elastic bands I would use to pair up everybody. It's the number of handshakes that these 12 corners have to make with each other. Lucas?
Is it because the 2 points can't be side by side?
Right. This 12 choose 2, and can you tell me what 12 choose 2 is, by the way?
66.
Is it 66? This 66, which is 12 choose 2, includes these 3 that I've randomly drawn, and I'm not going to attempt to draw all 66, but it includes this one. That's not a diagonal. A diagonal goes beyond saying connect any 2 vertices to saying connect any 2 vertices that are not adjacent to each other, that are not right next to each other. And there are 12 of those, so you have to subtract 12. Which gives you, if I remember, you said 66 minus 12 is 54. You may never be asked this question, or you may. What if I had a regular polygon and I told you there were 119 diagonals? How many sides are there? Well, we learned from the previous example that n choose 2 minus n is going to give you the number of diagonals. Right? If it was 12 sides, you go 12 choose 2 minus 12. So I don't believe that there is an algebraic solution to this that's appropriate for this class. I could be mistaken, but well, I might be mistaken. We're not going to do this algebraically. This is the kind of question that would be a numerical response. And you can just plonk away on your calculator here and pick a number. I don't know, maybe it's 15. 15 choose 2. 15 choose 2 minus 15. Well, it's more than 15. I mean, the wise thing to do would be to go to your y equals and put x choose 2 minus x and go to your list. Is it 17? It is 17. So this is a matter of, I suppose, trial and error and just knowing that for diagonals in a polygon, this is the case. That's it. I mean, there's tons more examples we could look at. But this lesson covers this section, combinations. We're done. Tomorrow we look at something called the binomial theorem, which we'll continue to finish off on Thursday. Your unit exam is the Wednesday of the week we get back. And then the following Tuesday is an in-class exam replacement exam. And I will post those dates and that information on Google Classroom. And finally, certainly before you leave, you'll get review materials for this unit and you'll get year review materials as well. Yeah.
Is that makeup exam like a field test on the computer, or did you make it?
It's my own exam.
Okay.
Yeah, I don't use the government field tests. So it's an exam, and the reason nothing against them, somebody's got to do them to give the government feedback, but they are literally field test items that some of the items they've never had any students write before, and they're just bad questions. You also run the risk of having an exam that's all permutations and combinations, because that's what they want to field test. Not all, but weighted that way. So no, it's my exam. So get to work. I just have to take my attendance, and I'll be around to help you out.